Thank you very much for the beautiful moderator, Miss Ratna. Thank you very much. Okay. Good.
15 minutes to present.
Okay. Thank you very much. Okay. Could the committee share my presentation, please? My slide presentation. Okay. Okay. Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Good afternoon, presenter. Good afternoon, all participants of this seminar, and good afternoon to committee. Thank you very much for the time. I will present about nano agri-food, nano coating at the application of fresh product. Next. Okay. I'm Dr. Suriati from Warmadewa University, Department of Food Technology, Food Science and Technology, Faculty of Agriculture, Warmadewa University. Maybe Dr. Nur, next time we can collaboration about our research, because direct connecting about your concern and my concern about the nano coating and essential oil. Okay, next slide, please. We know that domestic consumption and export increase consumer demand, especially a healthy diet, natural food, and organic ingredients, convenient, and food diversity. Next, please. Okay, and next, please. Okay. Industrial food product is needed a safe product, then increase the quantity and the high quality. Now, as develop the product of ready to eat, ready to use, and ready to cook. We know all of a community no have time to preparation about the food, and product of the ready to eat, ready to use, and ready to cook is the potentially to develop. And then some problem in the food production is about the post-harvest manipulation, and then storage technology, and the end is post-harvest technology sustainability. Because many product of agri-food or agri-product is lost in the change. Next. And the end of eco-friendly packaging is the one of potential material is to be developed, especially edible coating or film. Edible coating, maybe Dr. Nur has to already explain about the edible coating, a little bit about the edible coating. And edible coating of edible film is the material for various food that can be consumed or can be eaten with the food without removal the quality and shelf life of the product. Edible coating is consists of the biomaterial, biodegradable, that is the thin natural layer, and can prevent the moisture loss, selectively control exchange of oxygen, carbon dioxide, and ethylene in the respiration process. Right now, surface sterility and prevent loss other important component is urgent to develop. The thickness of the edible coating is maximum is 0.3 millimeter, and transparent needed the transparent film. That is the base of the coating. Next, please. Okay, this is the three phenomenon of edible coating or edible film. Is the first one is structural protection to prevent deterioration of biology, chemistry, and physics. That is protect food from the chemical reaction, microbial growth, UV rays, mechanical stress uh, from the nearby media. And the second one is carrier edible coating or edible film is carrier additive and active compound like the microbial agent, antioxidant, and coloring agent, flavor, and nutritional agent. The third one is edible coating or film as a barrier for gas, water vapor, solute, and lipid. Next, please. Uh, uh, Next, please. Currently, nanotechnology is a science that has become quite popular. That is a nanotechnology include the design, characterization, and production and application of the material, tool, or system at the nanoscale of 0.1 until 100 nanometer. And then they have received a significant attention in the food sector, including as a nano ingredient, nano emulsion, and nano coatings on nanofilm. That is nanotechnology is have a link of with food safety and food preservation, especially food packaging and security. And next. Nanomaterial for a food application is always as essential for food analysis, and then that is a biodegradable packaging or sustainable packaging, and then that is a smart and active packaging. And then this is depend on consumer perception regulation aspect, needed a safe and less risk of the consumer. Next. The advantage of nanotechnology consists of four advantages. The first one is antimicrobial ability. That is the nano coating interact directly with microbial cell and penetrate to the cell membrane and then oxidize the cell component or produce secondary product or that cause damage and then extend the shelf life of the fresh food. The second one is to improve of the mechanical properties such as flexibility, durability, temperature, and humidity. That is related to the interaction between nanocoating and additive and the matrix. The third one is improve emulsion system that the droplets are much smaller, which causes the decrease in the gravitational force, prevents sedimentation, cream formation, and flocculation. The tools are used include high pressure homogenizer, ultrasonic extractor, and a high speed blender. And the last one is bioavailability. That is the nanocoating increase the bioavailability to improve the absorption of bioactive component. The small size of the material causes the increase in the higher solubility rate and even dispersal. Next. Okay, this is the nanocoating component. Nanocoating component is consists of main component like the hydrocolloid and lipid. Hydrocolloid is consists of polysaccharide and protein. That is the sample of the polysaccharide is aloe vera gel, cellulose, starch, alginate, and pectin, or chitosan and carrageenan. That is the biomaterial. And then the protein, the material can be made from soy protein, with gluten, contain sunflower protein, gelatin,
whey, and casein. And then the material from the lipid group is wax, triglyceride, acetyl, monoglyceride, free fatty acid, sucrose, ester, and silac or resin. The other one, solvent, is can be used water or ethanol. And then the additive is the functional of additive is to improve or to modify the functional of this material and to improve the quality and stability and safety of the packaged food. If the additive to improve the modify and functional of this material, the example is plasticizer, cross-linking, emulsifier, and reinforcement agent. And to improve the quality and stability is the antioxidant, antimicrobial, coloring agent, flavor, and plastica. Next, please. Okay, this is the material from based on the coating or edible film based on polysaccharide, like microbial polysaccharide is leaven, ululan, and from the seaweed extract is carrageenan and alginate, and from the starch is dextrin and amylase, and from the cytine and chitosan, and from the cellulose is the M.Si, carboxymethyl cellulose, and HPC, and that's why. Next, please. Edible coating and film based on protein is can be used the gelatin, chain with gluten and casein, whey protein, albumin and gelatin, and soy protein, like the picture. Next, please. Edible coating of film from the lipid based on lipid is like a surfactant is the twin and lecithin. The functional as waxing is beeswax and carnauba or paraffin. Next, please. This is this edible coating and edible film from the female lakbark, silac, and woodricin, and so on. Next, please. If we use the edible coating, it can one edible coating or more. If more is we call the composite edible coating or edible film. Can be composed by the bilayer or conglomerate. Bilayer is a one layer deposit over another, like in the upper and the below. And the conglomerate is a mixture of several components in one layer. Mixed component. First of all, if we added the oil, essential oil may be mixed with the based on the material coating. Next, please. Next, please.
You only have 1 minute left.
Slide. Next. Okay. My research during 2019 until 2021, my concern is making formulation of edible coating based on aloe vera gel. The use of nano coating of aloe gel has great potential to provide new innovative and better result in horticultural productivity, post-harvest processing, efficiency, packaging, food quality, and safety through the detection of microbes that are harmful to human health. And currently, the efficacy in food product makes a significant contribution to deliver the bioactive compound. And I have the conclusion that the aloe vera gel is the good for fresh cut tropical food, because my research is a success to extend the shelf life of fresh cut food like the mango, rambutan, and mango skin until the 3 weeks. And then nano coating of gel can increase the bioavailability and control the release of active ingredient as well the input chemical reaction, and then reducing the impact of the sensory properties of the product. This is the performance of the aloe vera gel, and that is the inside of the leaf of plant have the gel, mucilage gel, that is we call the aloe gel or aloe vera gel. Next, please. Next slide. Next slide, please. Okay, this is the position of nano coating. That's why from the aloe gel, and we added the matrix additive as ascorbic acid, citric acid, and potassium sorbate, and then we stabilization with the heating of 49 degrees Celsius and for 5 minutes, and to be become a nano coating of aloe gel, and then we applicate in the minimum processing fruit like rambutan, mangoes, and mangosteen. That is can be solved the physiology, physical, and biochemistry or pathology problem damage. And then after application, the fresh cut fruit is become extended shelf life. Next, please.
Ibu, your time is up.
Next slide, please.
Make it fast a little bit because we are running out of time.
Okay. My research about the aloe gel and coating solution is for fresh fruit is on mangosteen is 50% aloe gel and 1 minute immersion time. On mango is nano coating with 1.15% additive in 50% aloe gel, and on rambutan is a nano coating of 50% aloe gel on 3 minute immersion time, and strawberry is non-nano is a safe.
Okay, due to time availability, I apologize. I have to cut it in the middle of your presentations because the time we have is very limited. We are moving to the next speakers. Ibu, thank you. I will be back to you into the discussion sessions. And the next speaker, we have Dr. Lee Bonbeng from Unimap with the paper entitled Value Addition in Fruit Products Using Encapsulation Technology. Apologies if I'm
Next slide, please.
Okay. We are ready in the next speaker, Ibu.
Slide,
I will be back to you. I will be back to you in to the discussion sessions.
Excuse me. Next slide, please.
Okay. Ibu, can you hear me? Can you hear us?
Okay.
Okay. I apologize that your time is up because due to the time limits,
okay.
I have to cut you in the middle of the presentation. But I will be back to you into the discussion session at the end of the seminar. Thank you, Ibu. Okay.
Okay.
Thank you. Thank you, Ibu. We're already moving on into the next speaker, Ibu. So we have Dr. Lee Bonbeng from Unimap with the paper entitled Value Addition in the Food Products Using Encapsulation Technology. Pak Doctor, times is yours. For the committee, please assist us to